Hi guys, welcome to another episode of MrLopezClasses.com. In this episode, we are going to talk about the wiring in an AC system, the marine air conditioning system. And we are going to analyze the wiring in this particular case for an split units with reversing valve. And we are going to analyze two types of thermostat. We are going to analyze the mechanical thermostat and the digital thermostat, the most common thermostat that you found it in the majority of the boats today. But the mechanical thermostat is also commonly used in marine applications. For that reason, we are going to check both diagrams. First of all, we are going to review the diagram with the mechanical thermostat. And we are going to analyze the connection of the control box of the system, the wiring connection of the thermostat with the control box, and the connection in between the control box and the compressor and the control box and the evaporator. This is a great video because in this video I hope you understand the procedure to do the troubleshoot in the future, because if you understand the wiring diagram, solving electrical problems related with air conditioning system is easy, it's not difficult. We are going to start here on the AC panel. This is the typical AC panel of the boat. The AC panel could be, remember in our electrical classes, could be double phase or single phase. Both scenarios are pretty similar. In this particular example, we are going to solve it as single phase wiring. The double phase, at the end, I explain what is the cable that you added. Okay, I have my AC panel. I have the main breaker, the sub breakers, small breakers, and one of those breakers will be for the air conditioning equipment. This is the breaker for the air conditioning equipment. That's the neutral bus bar, and that's the ground bus bar. And this is the mechanical thermostat. If you remember this thermostat is exactly like this, that the thermostat that we have on the screen right now. Okay, in this thermostat, we have three hubs. In the first one, we have three positions: off, air condition, or blower. Off, when the system is off, the first position is air condition. What is the meaning of that? Air condition is when the compressor and the evaporator, the fan of the evaporator, and the raw water pump are working together. This is air condition. In this one is only the blower, when you need mechanical ventilation inside of the room, when you need only circulate the air internally in your home, when you need circulate the air internally in your house. That's the situation. Okay, we have three positions: off, air condition, and blower. The middle one is for the RPMs of the fan, the RPMs of the blower, the RPMs of this blower. Okay, this is controlled here with a rheostat. It's a circuit, it's an element like this. Internally, you have a small circuit board for that hub. And in the bottom, you have the selection of heating or cooling. When you activate this hub, you activate the Y valve, and you send, I'm going to explain later, the fluid for this side or for this side, and this element works like a condenser or like an evaporator. That's wonderful. Depend on the position internally of this element, of this mechanism in the Y valve. Okay, this is the thermostat. It's clear. The thermostat sends the signal to activate the system. And this is the control box. This is the control box that usually you found it together with the condenser, together with the compressor and condenser in the engine room. In your home, that control box is located pretty close to the compressor and the condenser outside. It's exactly the same. Okay, we are going to check the elements that we have inside in the control box. In the control box, normally we have this board. This board is only to receive wires and send wires. This is a plastic board, exactly like the board that you have on the pictures. Okay, after that, we have the famous triac. The triac sends signal in two positions. Right now we are going to analyze. And we have the system start relay. Be careful because we have two relays. the system start relay and the motor start relay. The relay for the motor of the compressors, that's different. Two relays, ABYC question, ABYC question. Two relays, motor relay or compressor relay and system relay, because this is the relay that activates the system completely. Okay, we have the relay, we have the triac, we have the high pressure switch. In some control box, it's located here. In other ones, it's located here. But the cables enter here and here. It's a normally closed switch. It's a normally closed switch. The high pressure switch and the low pressure switch. Both of them are normally closed switches. What is the function of those couple of switches? Interrupt the current and stop the compressor and protect the compressor. Remember, the compressor is the most expensive part in the air conditioning system. And you need to protect the compressor always, all the time, because this is the element that circulate the refrigerant at high pressure and increase the pressure in the refrigerant. That's the heart of the system. Okay, the high pressure switch, we have the system relay, we have the start capacitor and run capacitor. Two important capacitors. Without the capacitors, the motor of the compressor never starts. The capacitors are vital components in this system. We have a start capacitor and we have a run capacitor. And we have the compressor. And the compressor, like I explained in previous episodes, they have one contactor, one switch, thermal switch, like the picture that we have on the screen right now, thermal switch over there, and we have the relay, the motor relay that I explained before, the procedure to verify if the winding of the motor is in good condition. You remember the reading between this and this plus this and this should be equal to this and this, yeah? I'm going to repeat again right now. Okay, that's the compressor. After the compressor, this is the discharge port of the compressor, high pressure supersaturated vapor, and this is the return, low pressure, low temperature vapor. Both of them. Remember, the freon, the refrigerant, enter into the compressor vapor. If the refrigerant enter into the compressor, liquid, damage the compressor. That's no good. That's one of the typical problems related with compressor. That the refrigerant is entering in the compressor liquid. Of course, immediately the compressor is damaged. The compressor is too sensitive. Okay, this is the discharge ports and this is the return port. And we have the blower here. We have the evaporator. And we have here the coil of the condenser. That the coil of the condenser, we have the Y valve, we have the raw water pump, the strainer, and the seacock. This is the system completely. And now we are going to try to understand how is that the current activate the system. How can I do the troubleshoot? It's not complicated, my friends. It's pretty simple. And we are going to follow this schematic. I hope you keep this schematic printed. Yes, you found a poster with this schematic in my web page. In the link posters, you found that poster. All right, my friends. Okay, quickly, we are going to analyze. We have hot, neutral, and ground entering in the control box. Hot, neutral, and ground, or in some cases it is double phase, hot, neutral, and ground. All right. Okay, the hot enter in the triac. The hot line enter in the triac, and the hot line is divided into hot lines. One hot line pass through the high pressure switch. If the high pressure switch is closed, it's normally closed. Only if the pressure of the refrigerant pass the limit, that switch open and avoid damage the compressor. Right? Okay, normally it's closed. The current pass over there, continue over there, and enter in the thermal switch. That's the thermal switch of the compressor. You remember what is the other name for that switch? Clixon switch. All right. Enter in the thermal switch, pass over there in the second position, and after that enter in the common position of the relay. Enter in the common position of the start relay of the compressor. Right now I have power here, but I don't have signal here and here. Why? Because I need to activate this section, the section of the capacitors. Okay, remember, in the triac divided the voltage, one voltage over there and other voltage here. Okay, what happened with the current that entered in this corner of the start system relay? Let me explain something about the system start relay. That small rectangle is that one, correct? Okay, the current enter here. We have a resistor over there. In other words, in this point, as soon as you have current here, for example 120, you have a little less voltage over there, 110, 112, because the resistor reduced a little. Everybody follow me? Okay, when you have current over there. Internally, in this start system relay, you have a thermal contactor that is normally closed. That thermal contactor is normally closed. Okay, it's closed, and immediately the current pass and charge the start capacitor. Okay, remember, as soon as you have power here, you have power here in one of the terminals of the run capacitor. And if the thermal contactor is closed, you have power on the capacitor and on the start capacitor, and right now the start capacitor is fully charged. And right now, when the start capacitor is fully charged, the temperature in this contactor increased. But in this moment, you have this power plus this power. In other words, here you have double power. You have the power from the start capacitor plus the current entering here. You have this power, that current, and this power. Okay, and right now, and this corner here is neutral. This corner on the start relay is neutrals. Those are the neutrals coming from the neutral and the neutral bus bar on the AC panel. Okay, this is the neutral here, and now the signal here is double signal. It's the signal of the run capacitor plus the signal of the start capacitor together. In that moment, the compressor starts. Immediately, the compressor starts, that thermal contactor open, and this capacitor is disconnected, and the compressor continue running only with the run capacitor. Simple, finito. That's the procedure to start the compressor. Remember, the cycle of refrigeration starts when the compressor starts. And right now the compressor is running. Yes, right now the compressor is running without this capacitor, only with this. Yeah? And the compressor is running. What happens if this capacitor is damaged, not supply the enough power? What is the symptom when the compressor tries to start? The compressor is humming, try to start but never start. If you check that capacitor, probably the capacitor is too hot or is damaged, is exploded in some cases. This is normally the capacitor that the technician replaces when the condenser outside of your home is damaged. The problem normally is with this capacitor. Okay, ready? Right now, the compressor is running, and bingo! We have the cycle of refrigeration working like I explained before. The secret is to start this compressor. Normally, when this compressor starts at the same time, you send current over there for the raw water pump, and the raw water pump starts at the same time that the neutral and that the hot line coming from that point. In other words, when the compressor is running, the raw water pump is running. In other cases, the current is coming from this point, not from this point. Doesn't matter. But you need to connect the raw water pump running at the same time with the capacitor. That's critical. That's the secret. For that reason, when you see the boat on the dock and you see the water coming outside, it's because the compressor is running. The compressor and the raw water pump are running together. Oh my friend, if the raw water pump is damaged, is broken, no raw water is coming out, immediately you have a lot of problems, because the temperature of the refrigerant in this coil increase, and immediately the high pressure switch open the circuit and stop the compressor. This is the procedure This is the procedure to start the system. This is the procedure to start the system. And with this hub, you calibrate the RPMs of the fan, the RPMs of the blower, in order to receive more or less fresh air. More or less, remember, when the blower is running, suction the air over there and send the air here. Oh, but where is the sensor? Where is the sensor? Oh, the sensor is here. The sensor normally is located here. Is in this particular mechanical thermostat is a capillary pipe. With a bulb, and the bulb is located over there. The bulb internally have a substance that expand and contract similar to the mercury, that expand and contract with a difference in temperature. Yeah, this is the sensor, and the sensor is connected directly with the thermostat. Of course. This element start according with this signal. What happens when the temperature that I select here is exactly the temperature that is in the room? What happened? The thermostat interrupt and no more current, and the compressor stop immediately. In other words, the secret to start the cycle is the thermostat. The thermostat activate or deactivate the system. This is the typical configuration. With mechanical thermostat. What is the meaning of that? When I have mechanical thermostat, in the control box, I don't have circuit board. I don't have electronic circuit board. I only have those elements. I have the system relay, I have the relays, the capacitors, I have the triac, but I don't have circuit board, electronic circuit board. No electronic circuit board when I use mechanical thermostat. What happened when I use instead of a mechanical thermostat, I use a digital thermostat. When I use a digital thermostat, the system is pretty similar, but here, instead of this and this, here we have the thermostat, the digital thermostat, and we have the buttons to increase and decrease the temperature, and we have the digital display. And we have one cable with the signal exactly the same like this, with the sensor located over there in front. In this area is where the filter is located. This is the filter that you replace periodically in order to keep the system running properly. Okay, you have the cable connected here to activate the thermostat. And also we have the circuit board here. The circuit board is located over there, and the circuit board have capacitors and diodes and resistors, and they have plugs here, and one of the plugs is to connect the thermostat. The thermostat is connected here. Sorry, I make a mistake. The sensor is located directly here in this position. That's the sensor in the circuit board, and also in the circuit board is connected the thermostat. And the thermostat send this signal in this output board, send that signal, and send other signal for the blower, and send another signal for the 24 volts AC 24 volts AC for the white bulb. Those are the output of the circuit board. In other words, it's exactly the same, but right now you replace one portion of the control box with the circuit board. Okay, the process in a typical air conditioning equipment starts here at the thermostat, because the thermostat is the element that you activate to select the temperature that you prefer, and this is the temperature that you wanted. If this selection of temperature is according with this sensor, this is the sensor that is located in front of the evaporator. The ambient air passes over there, and this sensor sends if this temperature is according with the temperature that you select on the thermostat. According with this temperature and according with this signal, this computer start a process. I am going to repeat. The circuit board have two input signals. One input signal from the thermostat. Other input signal is the signal coming from the sensor located in front of the evaporator to verify the temperature of the ambient temperature in the room. And with those signals and other power coming here, the main power enter over there, and internally the circuit board produced one signal for the system relay, system start relay, other signal to activate the blower, and other signal to activate the pump. The raw water pump or the pump relay that I am going to explain later. The system for relay, because in this particular case, this air conditioning equipment is working with the raw water pump dedicated for this coil. But in some boats, you can install only one raw water pump to activate different, to cool the refrigerant in different compressors with only one pump. This is efficient because you only need one through hole and you need only one pump. Okay. The capacity of the pump in gallons per hour should be according with the capacity of all the compressors working at the same time. That's the most important part. All right, but this is basically the wiring connection, the typical, of course, when I have an electronic thermostat, when I have a digital thermostat, one plug here, one small plug here is for those terminals. For the terminals of the Y valve, no? The terminals of the Y valve are connected here exactly like this one that we have on the chart. Okay, my friend, this is the typical connection. Okay, we are going to refresh the system and we are going to try to start the system again. Okay, the power, I have power here. The thermal switch is closed. I have power here. In other words, I have power in the motor relay, but the compressor no start. Let me verify if I have the neutral appropriated. Okay, the neutral is good, and let me verify if I have signal here. Remember, the signal is coming from this capacitor. But in this capacitor, there are one additional input. That input is coming from the system start relay. Let me verify. The system start relay is connected in the other end with the start capacitor. When the power enter here, we have one current over there and other one going directly to the start capacitor. In other words, the start capacitor and the run capacitor are connected in series. When the compressor starts, this capacitor is disconnected and the system continues running only with the run capacitor. Normally, the problem when the compressor not starts is the start capacitor. This is one of the possibilities. What is the procedure to verify if this capacitor and these capacitors are in good condition? The procedure to verify the quality of these capacitors is like this. What is the procedure to check the capacitors? Right now, I am going to explain the procedure to check the capacitors. To check a capacitor, you need a voltmeter
and you need to select the voltmeter in the function capacitors. What is the symbol for a capacitor? This is the symbol for a capacitor. That's the symbol for capacitors. What is the unit for capacitors? The unit is farads, microfarads, or nanofarads, or picofarads. Normally, the capacitors are rated in microfarads. Okay, I want to check a capacitor. You need a pliers to disconnect both terminals with a pliers, not with the fingers. You need a piece of wire to produce a charge on the capacitor in order to discharge the capacitor. When you have the capacitor outside, you can check on the label. In this particular case, the capacitor is in between, the capacity in farad is in between 189 and 227 microfarads. In between 189 and 227. Okay, after I discharge the capacitor with a piece of wire in between those terminals, I select my multimeter in capacitors. Let me explain the procedure. The voltmeter is off. Right now I go to this function. In this position there are two functions. The first one is for diodes, and the yellow one is for capacitors. Okay, I need the second one. I go over there, and now I press the yellow button, and I have the capacitors. Okay, and they say nanofarads. Okay, we are going to check how many farads I have here. And right now they have 205 microfarads. If you remember, this is 205. The capacity is in between 189 and 227, and I have 205. This capacitor is in good condition. If the reading is superior or less, you need to replace the capacitor for other one with the same characteristics.
Okay, right now we understand how those capacitors are in good condition. But the compressor no start. The start relay is okay, because I am going to verify the start relay. Once again, the procedure to verify the start relay is like this. In this particular example, we are in front of a self-contained unit. This is the compressor, and this is the evaporator. And now we are going to check the procedure to verify if the compressor is in good condition. The procedure to verify if the compressor is in good condition is checking the condition of the winding of the compressor. Remember that the compressor have two windings, one winding for run and other winding for start. And the procedure is like this. All the compressors, they have a common, start and run. Common, start and run. The reading between common and start plus the reading between common and run should be equal to the reading between start and run. Okay, we are going to verify in this moment that situation. This is the reading between common and start, is 2.5. And this is the reading between common and run, 0.9. And this is the reading between start and run, 3.2. In this particular case, this is a verification that this compressor is in good condition. And now I have the start relay in good conditions, the capacitors in good condition, but the compressor no start. What happened? What is the problem? The problem is a mechanical problem internally in the compressor. Because if the winding is okay and the current enters properly, the compressor is damaged. The compressor have an internal problem. That's 100% sure. This is the procedure to verify if the compressor is running in good condition. And this is the procedure to do the wiring in this type of boats.